In this video, I want to explain the derivatives rules for polynomials. First rule, d of x for x of n equals n x n minus 1. So as you can see here, you just put n to the side and then you subtract 1 from it. For example, if you have d of x, or the derivative with respect to x for x to the power of 4, that will be 4x to the power 4 minus 1, that will be 3. Next rule, d of x, or the derivative with respect to x for ax to the power of n, that will be a times n x to the power n minus 1. For example, d of x, 3x to the power of 4, so you keep 3 here, times, you put the 4 down, x to the power 4 minus 1, 3, that's equals 3 times 4, 12, x to the power of 3. Next one, the derivative for a constant. So d of x to c, well, c is constant, that will be 0. Okay? So always the derivative for a constant is 0. So d of x for 3, that will be 0. Also, we can say d of x to a different variable, to y, also that's equal to 0. And we will use this in the second derivative here. Okay, next one, when you add two terms, you distribute the derivatives. For example, d of x of ax to the power of n plus bx to the power of m, that will be d of x ax to the power of n plus d of x bx to the power of m. Okay, for example, the derivative with respect to x for 5x to the power 3 plus 3x squared plus 4x minus 17. So we'll take the derivative for each term of these, and that will be the answer. So first one will be 5 times 3x to the power of 2 plus 3 times 2x to the power of 2 minus 1, that will be 1, plus 4 times 1, x to the power of 1 minus 1, minus the derivative of constant is 0. So then that will be 15x squared plus 6x plus 4. Because x to the power of 0, that will be 1. Okay, so this is the answer here. 15x squared, so 3 times 5, 15x squared, 2 times 3, 6x, and plus 4. Next one here. The derivative with respect to x for 5x to the power 3 plus xy plus 3x. So now that will be 5 times 3 x to the power of 2 plus. Now here we deal with y as a constant, right? So that will be y plus 3. So the answer is 15 x to the power of 2 plus y plus 3. Now, what if I did the following example here? Let's put it down here. D over dy for 5x to the power of 3 plus xy plus 3x. So directly, there's no y here, so that will be 0. There's no y here, that will be 0. And the answer here will be x. Okay, so it will be 0 plus x plus 0. Because there is no y except in the second term here, so the answer will be x. Next example. So whenever you see number in here, that means how many derivatives you want to do, right? So there's no number, which means it's 1. Here, there's a number 2, so we need to do 2 derivatives here. Okay, so that will be 5 times 3x to the power of 2 plus y plus 3. The second derivative, that will be 15 times 2x plus 0 plus 0. So that will be 30x. Next one, we want to find the second derivative with respect to y. So that will be constant, so that will be 0, first one. Second term will be x plus 0. And then drive again. The answer will be 0. So you can notice here, if you have the highest degree or exponent for the variable you are deriving with respect to, for example, here with respect to y, so we are finding the second derivative and the highest degree for y is 1, directly the answer will be 0. Another example, so for example, find the third, if I say find the third derivative with respect to y for 5y x to the power 4 plus 6y squared. Here directly, because the derivative for 3, the third derivative, is higher than the 2 here, is higher than the maximum, is higher than the maximum degree for y in here, you just directly, the answer will be 0. Okay, next example. So find the third derivative with respect to x and the second derivative with respect to y. Okay, d over dx to the power of 3, dy to the power of 2, right? For 5x to the power of 5 plus 3y squared x to the power of 3 plus 5. So it doesn't matter really if you start with y or x. So you can start with a y or you can start with x, whichever is easier. So here, since we have two terms without y, right? So let's start with the y, so these two can cancel. So then d dx3 dy of, now this will become 0 plus this will become 2 times 3, 6y x to the power of 3 plus 0. Okay, then let's derive again with respect to y. So d over dx to the power of 3 of here 6x to the power of 3. Then really we need to find the third derivative, 6x to the power of 3. So that will be dx squared 6 times 3x squared, then dx for 18 times 2x, that's which equals to really 36. Or let me show you another way, tricky way. Whenever you have these two numbers equal to each other, like the derivative degree and the degree and the exponent x to the power 3, so both are 3, what you can do 6 times 3 factorial. So that will be 6 times 3 times 2, that equals 36. Or another example, if we have d of x to the power of 5 equals, say, 6x to the power of 5, that will be, since they are equals, that will be 6 times 5 factorial, that will be 6 times 5 times 4 times 3 times 2, which equals to 720. With that, we are done with the derivatives rules for polynomials for 1 degree derivative and second and third derivatives. If you have any question, please put it down in the comments.